So the curiosity of engineering, design, and just like in general, wanting to improve things, that relentless pursuit of how do we do this better really got us here.
Welcome to the Digital Smile Hub, the podcast that is dedicated to making clinical dentistry simple. Join us as we decode the complexities of dental care by providing actionable insights into the diverse aspects of clinical practice, the latest trends, and the newest technologies. Whether you're a seasoned clinician or just starting out of dental school, listen in on engaging discussions, expert interviews, and a wealth of tips and tricks to enhance your clinical workflows. So turn up that volume and get ready to transform your clinical practice with the Digital Smile Hub. And now, here's your host, Dr. Tim Anderson. All right, what's up, everybody? And welcome back. If you're a new listener, where have you been? But for real, we've got a lot of really amazing episodes and with some crazy, inspirational, cool people that you got to go back and check out. So if you're new, check out some of the old stuff. But also for the existing users and the existing listeners, man, you guys got to give us a like, share, tell your friends, give us a rating, all that kind of stuff. It's really important for us so that way we can develop this community. And speaking of community, with the 3D community, if you're not aware, we do have other podcasts within the 3D Dentist family, including Sully Sullivan's Millennial Dentist, T-Bone's T-Bone Speaks, and Aubrey and Meredith have their dental diaries focused on teams. So we've got a whole plethora of stuff that you can go check out. But, this is the Digital Smile Hub. So we talk about all things regarding digital or clinical dentistry, but with a little emphasis on digital dentistry. And I am so excited today because we get to focus on one of the topics that is near and dear to my heart. And we get to kind of hang out and talk with a guest that I've been wanting to talk to a little bit. So I'm a little geeking out. I'm excited about what's going to come today. But our guest today, he's the co-founder and chief product officer of a little known company that you may know called Sprintray. So we're super excited to have on the podcast today, Hossein Bassir. Welcome, man.
Hey, thanks for having me, Tim. How you doing?
I'm super excited because, like I said, you've been a guest that I'm excited about. And I think the reason I'm excited about it is because within my 3D family, I am like the little bit of the black sheep where I get a hard time from the standpoint of all right, Tim, you just got to get stuff out, quit overthinking it and putting so much emphasis into the way it looks and the way it sounds and the way it everything. And for me, design is such a component to who I am and is such a component to the way my practice is, how I impact my patients, to how my workflows are, that I love surrounding myself by a tribe of people that value little things like design. And my friend, you do design on a level that I think is just amazing. One of the things that always attracted me to Sprintray's products was not only the clinical outcomes of just good quality products, but it was the whole picture. It was the design. It was the user interface. It was how we use the products. It was it just made me feel good. So like I said, I am super excited to have you on. And yeah, I'm excited for users to kind of learn a little bit about you. And because you're not a dentist, right? You're not a dentist.
No.
No, you actually have a master's in literally industrial design, correct?
Correct. Yeah.
So tell us a little bit about how you went from, your backstory, how you got into the dental world, but, even before that.
Yeah. So I started doing industrial design back in 2000. This is where I was in Malaysia. I wasn't even in the US. So my first interaction with industrial design was when I went to school for it in Malaysia. Towards the end of, I guess, my 4-year degree in Malaysia doing industrial design, I was exposed to 3D printing for the very first time. Before that, we had to model everything by hand from foam, from wood, and different materials. I remember those days of spending hours and hours sanding things down just to get to. So some of the appreciation I have for, let me just open this parenthesis, for people who characterize things and spend time on dentures or hybrids. That's where it resonates a lot with me because I used to do that a lot, and that's very It's tedious. It's you have to be crafty and you have to know what you're doing. So when I see those pictures sometimes online that people have done this beautiful hybrid denture or a beautiful denture that is characterized, it captures me. Never thought we would end up in dentistry. Never thought I would be doing what I'm doing today. And that's, I guess, part of the beauty of, life in general. It just happens to be. But yeah, towards the end of my degree in Malaysia, I was exposed to 3D printing. For the very first time, it was amazing to just see that, hey, this thing that I did in SolidWorks, in our CAD software, now I can feel it. I can feel it in my hands without actually making it myself. It just came out of this machine. We didn't get to see those machines because we kind of outsourced at the time. This is 2008. Like, it's a long time ago. I don't think at the time there was any desktop 3D printer available to anyone. It was all industrial. So our class sent their entire CAD files, and then they got back the parts. And that was, again, the very first interaction. I left Malaysia around 2011 to come to United States. And I ended up in SCAD, Savannah College of Art and Design, to really finish my industrial design degree, getting masters over there. And that was where we started to see 3D printers in person, because we had them in the building, so you would go and work with them. Then I got an internship after that, and then that was where I got to use the 3D printer myself for the very first time. That is about 2012, maybe 2013. And then 2012, 2013, I'm working full-time at this company. It's the parent company for Rigid, Ryobi, those tools you see at Home Depot.
Oh, yeah.
And it was like at that time, it was a group of 20 to 25 designers just designing power tools, from the batteries, from the chargers, to the job site radio, to the drill itself, to circular saw. A lot of ergonomics were involved. A lot of branding was involved. So while you have to keep something ergonomically easy to use and comfortable to use over time, because these were professional tools. They were supposed to be used for hours and hours. So designing a handle at the right angle or the degree was very important for the people who are going to use that tool, because that's their bread and butter. That's the tool. Imagine that your handpiece wasn't that comfortable, that you had to use it for hours and hours. It would suck. So that was part of it. And then the other part was obviously the styling part of things, making them look like the brand, making them look cohesive from product to product. So if you have a bunch of Ryobi tools, they all need to feel like they're part of the family. So those were the times that I really learned how to hone down this. We used to call it visual brand language. Usually we just hear about branding and in general, but this was just like visual brand language for products that are hardware. And then I think this was, let me take a few steps back, because I have to explain my relationship with Amir too, like how did it all started. When I was in Malaysia, I got to meet Amir for the first time. And that was through his cousin. And Amir was there.
Time out. Who's Amir?
Amir is CEO and co-founder, the other co-founder at Sprintray.
There you go.
And we also have another co-founder, which comes into play later in this story. But for now, it's me and Amir. And then me and Amir, this is back in, again, 2007, maybe in Malaysia, that Amir's like, yeah, we got to go to America. We got to do, other things. And we were all, trying to get to United States at that moment, because we knew that this is the place to do all the things we want to do, You get to play, you get to make stuff, and it's all encouraged. So, yeah, I get to know Amir in Malaysia, and then I come to States, but I go to East Coast. And then Amir leaves Malaysia. He goes to USC, University of Southern California. And we keep in touch, and we actually tried a few projects. As I was working at that place, working on Rigid and Ryobi power tools, we were trying different ideas. Amir is always filled with business ideas, and he wants to try different things. So for one of those things that I remember, he was into cryptocurrency back in the days of 2012, 2013. And it was like, we need to make something that would automatically or remotely reset the rigs for creating cryptocurrencies. So this needs to have a GSM module, it needs to have this and that. So all it does is just cuts power and then brings it back up. And it needed a casing and a housing and some LEDs to just indicate what's going on, because it was just like a mini switch, essentially. And then we started working on that, and it just didn't go anywhere, obviously, because we didn't know what we were doing. It was just like, yeah, I have an idea.
Trial and error.
For it. Yeah, exactly. So that didn't happen. And there was another incubator at USC that Amir was a part of. And then we took there was another idea about something that today all Teslas can do is like, hey, where is my car? So you would just leave an object in your car and it would be able to determine which level of the parking, where you are, and with GPS and triangulation of that. And then today any Tesla can do that. So you see, like, the trend of ideas we had that didn't scale, it couldn't scale because it was just a tiny idea that what's next? You know, the question for any entrepreneur is usually like, okay, I have this one thing, but how do I scale it? What's next after this one product? So yeah, none of those things went anywhere until Amir gets to meet Jing, the third co-founder. Him and Amir both went to USC. If I'm not mistaken, it was the tech lab or 3D additive manufacturing lab, which was all focused on 3D printing. And one of their projects was around how do we build stuff on the moon, on the surface of the moon? We can't really take the soil from Earth to moon. So how do we use what's on the moon to create any sort of architectural pieces or any structures so we could live on the moon? It was just a concept that I think was spun by actually NASA. So it was a project given by NASA to that lab for these guys to figure out. So they ended up with making gigantic FDMs. The FDMs, for audience that is not inclined with FDM printing, are the ones that use a nozzle and then they heat up the plastic and they just trace a model. So those guys ended up with a big, very big FDM that actually used concrete. But not concrete. It was, let's take the soil of the moon and mix it and then bring it back into a material that we can build just cubes, just to begin with. It's like, let's say, can we just make 4 walls? So that was the premise for them. And they worked on that together, including some other students, PhD students. And I think through that interaction, Jing was very adamant that, hey, I want to do something. I want to take something to Kickstarter. And this is the time that I think Formlabs was the very first company that went to Kickstarter with some sort of a desktop idea. This is Form 1, the very, very first one. And I think those guys saw that and they were like, yeah, this is our calling. We need to do something similar to this. But then Formlabs used laser. And we know laser is inherently slower because it has to trace just like an FDM. So what if you use some other way? What if you use projection? Because they had all these tools available to them at the time in that lab, so they could experiment with different things. So I think this is the premise or the beginning of lights went off. The idea of like, how do we bring a low cost or affordable solution for people who are like the rest of us? They want to use 3D printing in general, but they don't want to wait hours and hours for something to finish. They want it quicker, but as a desktop plan. The only other thing at the time that was using DLP, if I'm not mistaken, was the B9 Creator. I don't know if you're familiar with that printer, but that was sort of a DIY printer. You would get a slide projector and you would get some structure that you had to put together yourself and then calibrate it and do everything to it. Imagine if you had to calibrate your Pro 95S by hand. So you have to really move that big projector up and down to get it to be in focus and all sharpness. And the other factor about that was it was fast, but it was using slide projector. And slide projectors are projecting the entire wavelength of light. But in 3D printing, we know that you either need 405 or 385 or 365. You need a range. You don't need the entire. So there was a lot of loss in that B9 Creator. There was a lot of loss of energy, loss of speed because of that. So these guys looked at and said, okay, Formlabs did laser, B9 is here, what is for us? And then that's where about the time that Amir calls me and says, and I'm still in Carolina working at the other job, designing power tools. And Amir calls me and says, hey, I have another idea. This might be the thing. I'm like, all right, let's do another one. Let's see how this one is going to fail and go nowhere. So we start doing that. And honestly, for me, I use 3D printers, but I have no idea how this thing works. So I have to get some crash course from Jing over the phone because he was also in California. Like, so can you explain to me what this is about? And he was like, oh, yeah, there's this tilt motor, there's a projector, and the projector was the same big projector at the time. And this thing was maybe not as tall as I am, but it was pretty tall, like when I saw the CAD file for the first time, and then I measured a few dimensions, I was like, Jing, this is not desktop. This is just as tall as I am. How do you put this on your desk? And, Jing is very unassuming, very humble. So he started laughing. And I'm like, is there anything we can do about the projector? Because the bulk of that height gain was because of the projector. So he says, yeah, let me see what I can do, So he goes back and comes back in a few months. And during this time, I'm just concepting, just trying to figure out what is the visual brand language for this thing, if we were to make it. And then I do some concepts. Usually in industrial design, you start with just crude concepts. You just put a box around something and you get basic dimensions out, you pick some colors, and then you think, hopefully you think about how you're going to build this, if any, because otherwise, if a concept has no regard for manufacturing, it will change a lot throughout the process. If you're not considering if this part is molded or that part is machined or this part is cast, you're going to end up having to slice that idea into those parts or those manufacturing techniques. And at the end of it, there's also the idea of assembly. And when we talk about 3D printers in general, calibration and assembly is one of those things that affects the quality of the outcome. So you really have to design something that is friendly to production line, to sourcing of the parts, in addition to manufacturing and all that. And on top of that, you have to make sure people can use it, people like looking at it, and they have a good feeling using it in practices. In that moment, we didn't know this is going to be a dental company. It was just a generic 3D printing company. And with the very first product, which we ended up calling it Moonray, and we put it on Kickstarter.
So was the Moonray from because you did all that? Was it because of the NASA project? And that's why did you name it Moonray?
Believe it or not, I think the name Sprintray was picked before even we started doing this, because Jing had this R&D house, more of a skunk work, that still is going on right now. That's our technology center. That he just has, at the time, I think he had 2 or 3 people working on these things, but now it's like a group of 50 people just doing crazy shit that ends up on our plate. We have to make a product out of it. So Jing works on that, and then he comes up with a smaller projector. And he says, okay, I'm pretty much done with downsizing this. So it went from something that was pretty tall to something that ended up being Moonray. The name of the Moonray came from a few concepts on the naming itself that we ran. So I think Jing's daughter name is Luna, and he was thinking about something about lunar or something that has to do with moon. But then we said, what if we just call it moon something? And you have Sprintray going on. What if this is Moonray? It's using that, again, that kind of brand language that is established with the name Sprintray.
Nice.
And we asked, what is the meaning of a Sprintray? And we asked him that. It was like, well, sprinting is fast, and then ray is light, so it's like fast light, stuff like that. I'm like, okay, I can work with that. So we redid the logo and everything. We cleaned it up once. Later, we changed it again to what it is today. But at that moment, he had like a basic logo. We did some visual brand language on that. And then we picked some colors. And if you remember, the very first Moonray, even though we had red in our branding from the get-go, but Moonray was green. Yeah, the reason for that was when I did concepts for Jing looked at them and I picked all sorts of colors because I had no idea that it has to block UV, I had no idea what I was doing. I was just like making it look good and, adding the sexiness to the product in that moment. So we do all that, and I put in front of him like 3 concepts. That one of them had blue color, which doesn't even block any UV. It's like useless. And then there's another one that is, I think, yellow or orange. And then that was automatically ruled out because they were like, nah, somebody's already using this for labs. And also Envision Tech at the time. So we really looked for something that was different. And then the green one just was the pick. Somehow it resonated with Jing. And honestly, in that moment, I wasn't a co-founder. I was just a contractor to do some industrial design. And Jing was really the founder in that second. And Amir was like, hey, let's figure out how we do this. Later, when we sat down together and said, okay, this could go somewhere, so let's think about how this involvement is going to go on, then I became a bit more insistent about like, oh, we need to do this, not that, because I wasn't a contractor anymore. I was like, okay, this is how it should be. Because before that, there was a lot of, both of them engineers, they were making some decisions. I was like, nah, but I couldn't say anything. Like, yeah, okay, whatever you like.
You're just going to just turn a blind eye. You're just going to pretend It's not happening.
So yeah, that's how Moonray became to be, and we took it to Kickstarter. It was really well received. We really looked for $100,000 at the time, but then we ended up having like 490, close to $500,000 we raised. And
well, I think that's amazing. It's important, I think, for me just to even hear the story, because so many times, like, let me backtrack a little bit. What's really important to me with how I treat my patients, how I interact with my friends and my family and everything is like really diving into like, what is your why? Like, we're really understanding what makes people tick, what's the core foundation behind the decisions they make and do that. And when I work with companies or when I'm looking at technology and anything, like, one of the things that's really important to me is really understanding like where you came from, like, does the culture fit my culture and all that? And I think you guys just have this amazing story of evolution as you guys, it wasn't like, hey, we just did this one thing and, rocked it out of the park. It was like you had all these other things where you started and you failed. And it's this journey of evolution and progression and learning from your mistakes and getting better and leveling up. And all of those things resonate, I think, a lot with a lot of dentists, because when we do things, when we're learning right away, it's like we have those failures, we have those things that don't go right, and we have to learn from them. And those that really push the boundary and learn from their mistakes and grow from those experiences, or call them learning opportunities, all of a sudden unlock this potential within their practice that they couldn't do. And I think you guys like nailed that at the park, not only from a business model, but then really almost stumbling upon the fact that dental became a niche for you guys that really, I don't think dentists or dental professionals, or even, honestly, I think even some of the Sprintray family really comprehend the long-term impact the three of you will have on the dental profession. And that's a really philosophical thing to say, but the reason I say that is when I look at dentistry, we have these moments, and I love digital dentistry. And so when we have these moments of like, okay, what's the most impactful thing on digital dentistry? And while I love photography and all that, yes, photography is really important. When I look at my digital workflow, there are two components that changed everything. And for me, the first component is intraoral scanning. And the reason intraoral scanning is the catalyst, we'll call it, was because it was the first time we had the capability of taking a physical object, whether that was a tooth, somebody's mouth, an arch, a face, or whatever it might be, and converting that into a digital file format, whether that's an OBJ, an STL, PLY, it doesn't really matter. But we had this capability to digitize the data. Mm-hmm. And the reason that's powerful is because all of a sudden it unlocks this capability of like, what can we do with this data? Now we can manipulate it. Before it was just stone. Like we had to like carve stone or carve wax. And now it's like we've got a digital file that we can manipulate and design and do stuff with. And it was like our brains started going crazy. The problem is the intraoral scanning technology has been around for over 30 years. Mm-hmm. And it never went anywhere because we were so limited. Yes, we could mill out an inlay, an onlay, or a crown, or if you were crazy, you could do a surgical guide. But we were so locked. We could not unlock the capabilities of that digital design and that digital power because we had no way to go from that physical to the digital, but then bring it back from the digital to the physical world, and so it can be impactful and actually be utilized. And that is where additive manufacturing changed the game. And 3D printing, I would argue, is the most pivotal moment within digital dentistry or any digital workflow because it unlocked the capabilities of the intraoral scanner. And it's not like one is better than the other. They're a marriage. You need both of them to do it. You need the digital data to print, and you need the printer in order to utilize the digital data. And so for me, you guys unlocked the next, I mean, you guys even coined it the next 100 years. But I do believe that most dentists, like we need to realize that this is what gives us power. This is how we transform patients' lives. This is how we can, improve smiles and empower our team members. It's when we have the technology and the workflows to do it. And 3D printing is one of those critical technologies that, you guys, everybody needs to be doing this. This is no longer a, hey, I'm into this and I have to like fiddle with it as like a little toy and, print fidget spinners like we did, 5 years ago, 6 years ago. This is now to the point where, Hussein, you were talking about, like, we're fabricating hybrid prosthetics. We're fabricating final dentures. We're fabricating final crowns. Like, we are doing things that were only figments of our imagination before. And it gets me really excited to see where you guys are taking this. And so, while I love 3D printing, what do you see as the current state of 3D printing and kind of where some of this stuff is going with 3D printers?
So over the past, now it's about 10 years. We're not even 10 years old as a company. It's crazy.
That is mind blowing, by the way, of what's happened in less than 10. So one of my sorry to interrupt you. One of my favorite quotes that I've mentioned before in the podcast is that we overestimate what we can do in a year and we underestimate what we can do in a decade. And I think you guys are a perfect example of, like, 10 years ago, there's no way we could have thought in a million years we'd be doing what we're doing with the products you guys are creating.
Yeah. No, it's humbling at the same time. We are very proud of what we have done. But really the reason behind it is curiosity. From day one, we were like, how do we make this better? Why is it slow? Why is it the way it is? Why do we have to tilt from Moonray? Remember, whoever had a Moonray remembers that it had to tilt between every layer. And then when we were looking at it at the time, I mean, we knew as much as we knew at the time. We were like, how do we make this faster? Well, one thing is get rid of that thing, because it used to break a lot too. So the curiosity of engineering, design, and just like in general wanting to improve things, that relentless pursuit of how do we do this better really got us here. That's if I have to sum it up. But I think that's more of it's not just us. I think whoever is very focused on a topic and keeps reviewing that topic from the beginning till end, they find issues about it. They find ways of improving it. Nothing is ever perfect. But also getting to perfection means you have to do a lot of iteration. And that's really the basis of how we do what we do at the Sprintray. There is also this other factor of, hey, we have to run a business. If we want to keep doing this, we have to be able to say, okay, at this moment, we are done with this much improvement. Let's put it out and then learn from that and then do another round of improvement. Dentistry really for us started as a relationship with Glidewell. And everybody knows Glidewell. And those guys were really telling us a lot of things about using Moonray because they had a Kickstarter unit. From there, we started learning about how we can improve these things, and just basic stuff was about software. Like, the hardware was good enough for them. They were like, can you do more software things so we can control a fleet of them? So it would make sense for us to, as a lab, to use them. So you see, we started picking up different things from different people. Some doctors are starting telling us that, your model resin doesn't smells. That was the beginning of the time. And then we were like, okay, we have to remove the smell, because if we want this to be chairside, if people want to use it, then smell is a problem. So we kept just hammering these issues. And every now and then, I was actually explaining this to somebody on Facebook group. Every now and then it makes sense to collect these changes, big improvements, and then pack them into a new product. And that's why we went through so many iterations in the less than a 10-year span to get to where we are. How do I see 3D printing moving forward? I think in the past 5 years, since we really got serious about 3D printing in dental, because at the beginning we were not so much about just dental. It was a generic 3D printing company that can be anything to anyone. But as you mentioned earlier, we had to make this decision that who do we cater to? Because if you really want to customize the product, if you want to make a workflow solution, you cannot just take care of everyone. You have to be razor sharp about a group. And most of the credit for that decision goes to Amir. He was the one talking to many people at the time, from jewelers to dentists to just prototyping people or to artists that wanted to buy the Moonray at the time for doing just sculptures and things. He was like, we need to change our strategy. We need to go into dentistry because it looks like for dentists, the price point is actually too cheap. they don't believe it that this thing that can do these kind of stuff is this low. I think at the time it was $5,000. And everybody was like, what? $5,000? Is this a toy? That was a question we used to get. It's like, does it work? I'm like, yes, it does. And then from that standpoint, we started looking at the entire workflow, not only just printing. We started with one 3D printer, but then later we quickly came up with a Procure One, because we knew that, okay, for doing models and surgical guides, especially for surgical guides, you really need to cure this before autoclaving. So that's the beginning of the origins of thinking about workflow. Today, we think less about just one piece of it. We think about the entire thing. And when you think about the entire thing, you realize that you have different levers and buttons to push to get to the final result. Something that cannot be done in the printer maybe can happen in the cure box, or maybe the washing machine can take care of some other things that the other two cannot. Or maybe it's the resin itself, which is the most important part of it. To be open and transparent, everything is driven by the material. If we have to pick a different technology for the curing machines, or for the wash machines, or for the printer itself, it's all driven by this concept that I need to get to the final appliance. That's what matters to the dentist and to the patient. Like, nobody really cares what kind of things you have to go through to get to this final appliance. It's all about that. So when you think about dentist workflow from that standpoint, you end up figuring out, oh, okay, I have a gap here, I have a gap there, there's this broken piece here, there's that interaction that is not so good. Then you start just refining those things. You talk to your customer, you get to know their workflows. And in dentistry, what we have learned is that everybody has their own preferences. It's never the same thing. Like, somebody bonds it this way, the other person prefers to do it the other way. And they have very strong opinion about how it should be done.
Excellent. Stupidly strong opinions.
So we as manufacturers, we have to keep the system guided, but open enough for people to experiment with different things. Some people, in our workflows, we say, okay, you have to print a hybrid this way, but then some people want to change that. We cannot lock them into that. They want to do what they want to do. To some extent, I think these tools are also meant to open up imagination for people. They're not supposed to be just like, hey, do this, or just follow this workflow. Even though they're designed to be one click and print, one click and do this and that, so you could do that. And I think that's necessary because many dental offices, we observe that people who use them are not the ones who actually made the purchase. The purchase was made by the doctor, but it's being used by the assistant or by the receptionist. Like, some of these guys are trained because, hey, we need help 3D printing all these models today. Everybody, jump in. Press this button, press that button, get to the end,
And I think that's one of the actual core things. That's one of the things that I believe in to true integration and success is that team workflow and making it easy for them. Dentists are notorious for wanting an easy bake oven. Hey, we just want to click it and forget it. And I love that you talked about how we're, some of that creativity. Because when I look at like what I do with a 3D printer nowadays, I'm like, a lot of that was like, could you do one thing and then you're like, can I do this? Like, let's try this. And it really does become fun, but you start seeing your team members and that's where the offices that really maximize the technology, any technology, it doesn't need to be 3D printing. They're the ones that are empowering their team. You want to have the least trained employee doing the minimal thing that they can do. So if my team member can do the 3D printing, they should be doing that because I have a skill set that is outside their scope that I should be doing this. And what you start seeing is the culture around that. Where I think you guys, I think the reason, like the magic behind a lot of the integration and why 3D printing, like for those of you that have been holding off on 3D printers, like, I don't know if I need it. I don't know if if you're going to wait for the next thing, if Sprintray has taught us anything, it's that there is always going to be something new and it's going to come out way faster than we thought. And so the key is integrating the workflow. And once you get on board and learning the workflow, what happens is everything just kind of builds on itself. And what I love is that when you have technology that marries design, hardware, and most importantly, software, all of a sudden the barriers to saying no disappear. And it just becomes this workflow that is like, I can't look at it any different. Like, digital dentures literally changed removable prosthetics overnight from the standpoint of like it not only changed the material what we're making them out of, but it changed the workflow. And when you see the workflow, you can't unsee it. And that's where like you guys keep pushing the innovation of workflow and AI. Like I'm blown away. Like if you guys have never tried the occlusal guards, like the AI occlusal guard workflow that Sprintray has, like you have to try this because if you're like me, like a lot of us didn't want to design it. We're like, I don't want to be the lab technician. I need something else. This was a great way to just scan it, send it to the cloud, have AI design it, literally goes to your printer and you hit print. I mean, the workflow couldn't be easier. So we're beyond the days of like having to hack the system to figure it out, making a non-dental printer work for dental. We now have dental specific ecosystems and workflows that it just becomes a no-brainer. Like I just, to this day, I can't emphasize enough, like we have to have printers in every office.
Yeah. No, I mean, you brought up a great point. When you have digital input, which I think should be standard of care by now. Like I wouldn't go to a dentist that doesn't have an intraoral scanner, especially in the United States, especially in California. Like, what are you doing if you don't have one? Come on. If you have that input, as you said, you need an output. You need a way to bring it back to life. And mills were great for the time, and they're still rocking a few areas very well. But when you think about the footprint of a mill, the cost of the mill, and the just overall a mill experience, it's very mechanical, very much. I mean, we still do that. A lot of the parts in these 3D printers are milled technically. They're CNC for precision. But when you think about, I want to have and dedicate this much space or footprint to a machine that can give me the most ROI, 3D printers in general, not only just Sprintray, just 3D printing blows any CNC machine out of the water because it can do anything you want. It doesn't have any limitations whatsoever. The only limitation, which I think goes back to your question about where 3D printing is going to go, is the limitations of materials. But guess what? Somebody like Sprintray only started spending really R&D dollar on materials 6 years ago. In 6 years, we got from just a model resin and a surgical guide resin to now almost anything. So imagine another 6 years where this is going to go. And some of it is enabled by hardware. The hardware that we have put out in the past few months, the Pro 2 and Midas itself, those are designed to unlock the material development altogether. And speaking of a Pro 2, just one basic factor on that is the change of wavelength. We used to have a 405 in all our printers before Pro 2 because it was, and it still is, one of the most popular wavelengths. But when you purely think about dentistry, which it demands a level of accuracy and fit and finish that nothing else demands, in addition to great anatomy and smooth surfaces, everything that you essentially, I think dentistry is one of the most demanding fields for 3D printers because it needs to balance, it needs to be perfect, near perfect product. It needs to come out of it, which is very difficult to nail. And throughout the years, what we learned from shipping all the printers we had was that resolution is only part of it. Like we increased resolution with 55S from 95S, it doubled up the resolution. The resolution was good. But still you were like, okay, this is still not there. Still, even though print's really great, but I know we can do better. And that's where we thought about changing the wavelength because in our internal testings, just a simple, let's use holes on a stackable guide. Those are the areas that are very tough to really print without supporting them. And you can't really support them because you have to print them so they could fit the fitments that they need to go through them. And it was difficult. It was really difficult to properly print them with any 405 printer. And then once we changed to 385, you just see those holes coming out perfectly circular and without any support. So you see how the same material, Surgical Guide 3, is now even more capable to do just because of better wavelength and just better pixel density, which comes from the optical panel on the Pro 2. The other aspect of, speaking of Pro 2 a little bit, we use DLP projectors in all our printers. I think those are great pieces of technology, And there is still use for them for 3D printing, even at Sprintray ecosystem. Midas uses a DLP projector. It's not optical panel. But then we wanted to increase the throughput on the Pro systems. And instead of having two printers that you had to figure out which one is the right one for you, we wanted to make one printer that you just easily buy and service yourself if necessary. You could not calibrate a DLP projector on your own. If anything went wrong, you had to come back to us. We had to do stuff to it and then send it back to you. But now with the optical panel technology, if anything happens, or if you want to upgrade it, you could just swap it out very easily. And it's self-serviceable for the most part.
And what I love about some of these newer advancements in the printing hardware that you guys have really kind of pioneered is that it really touches on some of the pain points that many of the users have had for years. And I love 3D printing, but nothing is worse when you spend all this time. And, I came from the days of a laser printer, an LCD. And what I found was that one of my biggest pain points was print failures. Mm-hmm. And you spend all this time and you'd be printing all these models and then it fails and you're like, oh, this wasn't even worth it. And I think some of us still have that mindset a little bit of like, I talked to a guy and he said it doesn't work or it fails or it's messy or whatever. And what I would challenge you to start taking some of the input from existing users that are maximizing technology and using it, and not people that are not using it. And one of the things with regards to the hardware is that the predictability. Like this new wavelength, I will say, like I've been using Sprintray since the Moonray S days. What I will say is that the predictability of print success is exponentially higher than it's ever been. Mm-hmm. And while like the 95 was great and the 95S was great, like it is so rare to have a print failure as long as I didn't try to do something crazy with the data. Like as long as it's just a normal data and a normal scan and everything, like print failures are it's almost a thing of the past in my practice. Like it just really doesn't happen very often. And I think that's important for people to understand is that the way printing was a year ago, 2 years ago, 3 years ago is not what it is today. And I'd encourage everybody to just kind of like, you kind of have to go into things with an open mind of like, what could this be? What can this be? And the systems are just so good. The other thing that I think is amazing that has changed, and you can kind of dive into a little bit like the why this happened, is that, when we don't understand technology, we're human. So what do? We just base everything based on price, right? And one of the things that you cannot do is a printer is not a printer. We talked a little bit here tonight or today of like, we've got FDM printers, we got DLP printers, LCD printers, like there's all sorts of printers, like calling a dental laser a laser, like they're all different. Mm-hmm. But one of the things that is important to understand is that there is a reason behind the technology and there is very big differences between them. And so while one printer may work for one person, may not have worked for another, I think it's really important to understand that the printers themselves are very different. And so these changes that you guys have changed with the wavelength is not just a number thing. It's not like, oh, we can make it because the printer's cheaper to fabricate now. There was a very intent reason. It helps us unlock the capabilities of new resins that, like you said, resins are key. Like that is, anytime somebody wants to buy a printer, the first thing I always ask them is like, what do you want to print? Like what a problem are you trying to solve? Because many times you can buy a really, really quote unquote cheap printer, but all you can do is a model with it. Like you can't do nanofusion hybrid materials. You can't do ceramic materials. You can't do the newest generation of surgical guides. Like you just need to understand what you're getting into. Now, I do want you to talk about, because one of the big changes that we've seen in the last couple of years is on the post-production side, specifically with the post-production curing cycles. And you guys totally reinvented the wheel on the curing process. You guys are exponentially faster than anybody else on the market. How is this possible?
Taking it seriously. I think everybody thinks about washing and curing as just an afterthought. They're like, yeah, just put it into the thing and turn it on. Wait for it. But when you really want to do chairside dentistry, not only it's the aspect of time that needs to be compressed, but also the quality of the outcome. So we did Procure 2. Procure 1 was really a basic curing machine. And whoever is still rocking it, good job. But when you go from Procure 1 to Procure 2, you see it 10 times faster speeds and power and the quality of the outcome, even though you may look at both outcomes from Cure 1 and Cure 2, and you can understand the time compression, but you can't tell the mechanical properties that changed because of the better wavelength, because of the consistency, the heat that we give it. From Procure 2, then we learned a lot of lessons that moving LEDs makes life more difficult, especially when you want to control shade. And shade is one of those really, really difficult things to get right in dentistry. From the material side of it to curing side of it, it's just one of those things that has broke our back in terms of, figuring this out so we can manufacture it properly. But we learned a lot from just the experience doing Procure 2, not only because of the size of it, like we collect data anonymously from all these machines. And it was obvious that a lot of people didn't utilize the entire platform on Procure 2. They were using just mostly half of it, which was the basis of the idea of NanoCure. That, okay, if people only use some of this, let's say the majority, the super majority did that. What if we just make this smaller? By the virtue of making it smaller, you also condense more LEDs into it, so it increases its power. Then we also learn about other wavelengths we could put in there to further increase the mechanical properties and, again, quality of the outcome, shade reproduction, all that. That was the genesis of why we did NanoCure. And now when you put NanoCure against Procure 2, well, Procure 2 is good for certain things, especially if you're printing in volume and you want to print and cure them in volume as well. So that just is a perfect machine. But for almost everybody else, NanoCure delivers great mechanical properties, faster cure times, and it's also more compact and it's quiet, silent when it runs. So almost everything you want and expect from a curing machine. Why we did this? Because we are curious. We are curious about, we nailed down print times. It's very fast now. But then when we get to curing time, we are slow. And that's something that I guess was okay for everybody else except us. So we really took on that challenge of like, what can we do with this? And I think today we see some other manufacturers are maybe starting to pick up on these notes that, this is also important. We shouldn't just think about the printer. And that's really workflow thinking. It's not like just because we could do this technology, let's do it. We really think about how do we do better shade production? How do we do better with being chairside friendly in terms of size, noise, and time? Because it's all about time at the end of the day. So yeah, that's why we took that part very, very seriously and ended up where we are. And I don't think it's going to stop at NanoCure. NanoCure is definitely a great step forward in the right direction. With Procure 2, we tried different ideas. It was more of a, let's take this concept that has different things built into it and then put it out there and see how it does. Again, still a great machine, whoever has it. It's a beautiful machine. It's a great machine for volume. But if you have smaller volume and you print per patient, NanoCure is your best friend.
Yeah, and it's crazy because it's funny how a little thing makes a huge difference. I mean, it was just one of those aspects, the footprint smaller, everything. It just made my workflow easier. And so what I love about this whole topic is that technology is continuing to evolve. And we are on the kind of precipice of like the next evolution of what's coming. And we live in this time right now where this is the best time to practice dentistry, you guys. Like, there's not a better time. We are finally able to do all these things theoretically that we wanted to. I get really excited about what AI is continuing to change for us, not only from a design standpoint, but also predictability of how our whole ecosystem and workflows work. But the hardware continues to just evolve at a pace that even to this day, I'm just blown away by. Like, I look at all this old hardware I have, and I'm so grateful to have had it and used it. Like, I like Marie Kondo, that whole like minimalist thing. I'm like, I saw it, I gave it thanks, and then I put it in the closet. I moved on, and then it's the next one, so that way we can continue to maximize the workflows. But what you end up starting to see is that when you start maximizing this digital workflow of intraoral scanning and additive manufacturing, it changes the culture within your practice. It changes the culture within your team. It changes the way your patients look at you. And what it really does for me as a clinician is it changes what's possible in my own clinical armamentarium. I'm able to do things that I could never, ever do before or imagine. And honestly, Hussein, it would never have been possible without the advancements you guys have done. So I am eternally grateful. Like I said, this is not a Sprintray podcast or anything, but I wanted to bring you on because I am so grateful for what this technology has done to my practice and to my team, and everybody needs to get into this. What I also want to do is I have to have you come back, because while I love 3D printing and I love this form of additive manufacturing, while most companies and most of us have been trying to reinvent the wheel and how we get somewhere, Sprintray reinvented the frickin' road. And they are taking us on a different technology because you guys have just introduced a completely revolutionary is like one of those keyframes everybody uses or key terms everybody uses, but you guys truly reinvented how we will be manufacturing moving forward. What is that called?
It's called DPS, or digital press stereolithography. And the origins of that idea was around how do we print highly filled materials? Because we know one of the limitations of existing 3D printers, like this applies to all of 3D printers that we see desktop, is the fact that there's a print platform, there's a resin tank, and you have to pour resin into it. And between layers that it prints, it needs to wait for resin to replenish. And the thicker the resin is, and especially in dentistry, we add a lot of additives, a lot of fillers, you have ceramic infused stuff. So when you want to really go with high concentration of those things to improve mechanical properties or translucency of the material, or just for that matter, improve the resin itself, you end up with a very thick material that becomes just like a toothpaste. And conventional 3D printers cannot handle that. They have to either wait a very long time for, imagine honey. Instead of being like water-like, it's more like honey-like. So it will take some time for resin to come back for the next layer. So that really was one of the limitations in front of us to increase the amount of ceramics, for example, in any of the resins. On the other hand, I think one of the challenges that some people face, especially people who are less patient with technology, let's put it that way. We're trying to manage resin tank and platform, keep them clean, make sure this and that. There's this maintenance part and aspect of it. We use this internal analogy of espresso machine versus Nespresso machine. So espressos are the desktop 3D printers that we have, like Pro 2, Pro S, Pro, Moonray. They were all the espresso machine. Now, if somebody just wants something very quick, if I want to enjoy a coffee super quick, I don't have to learn how to be a barista. I don't have to learn what is a portafilter, how do I grind my whatever. So instead, we thought about this machine that could really ease people into 3D printing and actually maybe resolve a lot of the headaches that some people had with running the desktop machines. So 2 things to recap is ease of use and ability to print any viscosity of material. So how do we make a machine that is agnostic to viscosity and it's just exponentially easier to use and requires really close to no maintenance whatsoever? You don't have to do anything. And that was the origins of Midas, which ended up being, we just announced it, and I think we are starting to ship it in a month or so. But really, the genius behind that goes back to Jing again. And if you ask him, like, how did you come up with this idea? He's going to be very unassuming and humble about it. It's going to be like, oh yeah, this is the Pascal's law of whatever. You press on one thing, the other thing goes up. Yes, but Jing, nobody else thought about this. Nobody else thought we would print with this method. So yeah, since I think 1984, which was the original patents of the desktop SLAs, something that we still use and we continue to use that format for where it makes sense, this new format just introduced in 2024, well, essentially 2023, because that was where we actually patented it. But it took a year to turn it into a product that we can actually announce. So in 2024, we announced Midas, which uses DPS, digital press stereolithography. Essentially what this does is that it compresses the material and presses it through the printing process. And everything happens in these capsules that I encourage people to go just look up Midas 3D printer, and the webpage on our website, it goes through entire details about it. There are many good animations showing how this works. But essentially, this thing is now containing resin tank, and print platform into one capsule that is very reminiscent of Nespresso pods that you just pop into a machine and you press print. So with Nespresso, you get a coffee out of it. With these, you get restorations of inlay onlays, crowns, veneers. It can print up to 3 crowns at the same time. It can print up to 9 veneers at the same time. It can print all of them mixed and matched at the same time. Everything is almost less than 10 minutes. If you have a smaller geometry, like some inlay onlays, takes about 3 to 5 minutes. It's all about what you're printing. So this really drastically changes how we think about 3D printing, from being this machine that you have to take care of some things, you have to maintain it, to something that you don't even think about it anymore. It's not part of the equation anymore. We have been using it internally for a while. And now we are beginning to, we did a lot of, since we launched it and unveiled it, we have done a lot of internal demos for all the guests coming in to see it. And unanimously, people look at Pro 2 and they're like, oh, it prints so good. But then once you show them Midas, they just forget about everything else. They're like, I need this thing. I don't even know what I'm going to do with it. But because of its size, which is now as small as a nanocube, the ease of use, and just like the magic behind it, it just, you don't see what's happening inside, but just in 10 minutes you get a crown. It just blows everybody's mind. So, yeah, I'm still getting.
It's crazy because, like, you talked about how, like when you saw 3D printers, like, you just like this cool concept, and that's like this new technology. This is why I'm so excited to have you on, and this is why I'm excited about these topics of where digital dentistry is going, because this is like the first time I'm looking at a product of any kind and going, this is a totally different way of doing things. Like, this is not just a new 3D printer. This is not a 3D printer in our traditional fashion. This is not a mill. It's not like, this is a new technology that I look at this as the stepping stone truly for the next evolution of how we provide dental care in our current workflows. Like, this will transform how we do things. And I get really excited about not necessarily a product or like a new gadget. I get excited about workflow changes, like things that are going to move the needle and change how I look at my patients, how I look at my practice, how I interact with my team members. This is just going to change things. And I'm so excited about, like, literally, like, we have to do a podcast literally just on digital press stereolithography, because that is a concept that I think if you aren't familiar at all with it, and please do check out their website to learn a little bit about this stuff, because it is not replacing, like, this does not replace my 3D printer. This is a totally different way of additive manufacturing to unlock even more potentials with my practice. So this is going to be a great addition to my interior workflow. But where I get excited is, where is this going to go? Because what's getting excited. You guys made an announcement that, you've got some really amazing partnerships. You guys are working with Ivoclar materials. That gets a lot of us geeky dentists really excited, because we know what they mean behind their material sciences and their research. So you guys are just like kicking it out of the park. Hussein, I got to have you come back. We're gonna talk about some of the press stereolithography, but I mean this from the bottom of my heart, dude. I'm so excited to have had you to have you as a friend. You guys are doing some amazing things. Everybody, if you need it, like, reach out to me if you want to know more about the 3D printing workflow. Reach out to Hussein. The Sprintray family is a great group of people. They're more than happy to have you come into their facilities and kind of check out what they're doing over there. But ultimately, everybody, you just need to move forward. You need to integrate additive manufacturing into practice. I don't even care what kind of manufacturing you do or what printer you buy, but you have to integrate the workflows. And I promise you, if you add the technology, the workflows are going to be important. And there's a reason I use the Sprintray ecosystem. And it's because you guys hit everything on my docket. So I appreciate you, man. Thank you so much. If people need to get a hold of you, how do they get a hold of you?
I'm always pretty active on our group on Facebook. You can send me direct messages. If you need to send me an email, my email is hb@Sprintray. It's my initials, Hossein Bassir, @sprintray.com. Yeah, reach out and let's talk if you're interested in using any of these machines or you're interested to know more about them. And by the way, thank you so much for all the compliments you gave us. I tried to keep them for the end, but we really appreciate it. Part of the fact that we are where we are is you guys. You guys put them to use. You give us feedback, and we learn how they could improve over time from the clinical standpoint. Without the input, without the honest feedback, it would have not been possible. It's not just a bunch of engineers figuring this out. It's the actual, we do something, you guys use it, you tell us what's wrong with it or how it could be better, and then we make it better in the next generation. So we also appreciate the partnership and your trust in the products that we make.
Well, man, it goes both ways. So thank you so much for everything, you guys. Catch us next week when we got another episode for you. Once again, like, subscribe, share it with your friends and colleagues. And until then, keep smiling, and we'll see you guys next week. If you enjoyed this episode, be sure to subscribe so you get notified when all the new content is released. And don't forget to rate, review, and share this podcast with all your friends and colleagues. For more information about all things happening within the 3D Dentist family, follow us at www.3d-dentist.com. Thanks for listening, and I hope you are leaving with new insights to help transform and level up your practice. Until next time, keep smiling.